So let's take up the next statement, which will help us increase our SQL query performance. Keep index size as small as possible. Now, let me explain what this statement means. Let's say that you are given a choice to choose between two columns for indexes. Let's say that one column is of int data type and the other column is of numeric. Then according to this statement, what it means is that you should make the choice of int rather than numeric. Why? Because int is small in size as compared to the numeric data type. So let's try to validate this statement and understand how does the choice of index size increase or decrease our performance. Before we go ahead and we validate our statement, let's try to understand how actually SQL Server stores data. Now at the top level is your MDF and LDF files, your actual physical files. So you can see that at the base level or at the top level is your physical files. These files are further divided into something called as extent. Now extents are nothing but their logical grouping of pages. So the extent is further divided into pages, and inside the pages is your actual data row. So you can think about pages as a fundamental unit of storage. Now these pages are approximately of 8 KB size. So for example, let's say that you have a table which has 100 rows. So it's possible that it can move the first 50 rows into page number 1, and it can move the second 50 rows into page number 2, depending on how much is your row size. So your total 50 records row size should be fitting into 8 KB. Okay. So just revising what I said about pages. Pages are your fundamental unit of storage. Pages are approximately of 8 KB size, and pages are the actual object in which your data is actually stored or your SQL row is stored. Now let me make a statement here. The more the number of pages, the more SQL Server engine has to jump between pages to fetch a record. And the less the number of pages, SQL Server can browse quickly to get the row or the SQL row or the data row. Now, what does it actually mean? Now let's say that you have a table which has 100 records, and let's say that all of these 100 records are of 8 KB size. So the total size of the 100 records is 8 KB. So it has fitted into one page. So here SQL Server can quickly go and browse to that page and can go and browse to that record. It doesn't have to jump between these pages. Now let's say that these 100 records are pushed into two different pages. Then SQL Server has to make this jump between pages to fetch the record. And this jump is a bit of a resource intensive. So in other words, when you whenever you select a data type of int, or whenever you create an index of an int data type, that means the pages required will be less. The time you increase the size of your index, that means the data row will be spanned into more number of pages, and this jump will be required. So let me demonstrate practically that how when you choose an int data type, the number of pages are less, and how you actually when you choose a decimal data type or when you choose a numeric data type, how actually the SQL Server pages increase, and and that actually increases the performance because of this jump. So here's a simple table I have, which has basically 3 fields: customer code, customer name, and register date. And what I've done is that I have created an index on the customer code column, and the customer code column is an int data type. Okay. Now what I've done over here is that I have actually queried my internal system tables to get the size of the SQL index. So here's a simple query I have, and this query basically queries the sys index table, and it makes an inner join with the physical stats table to get us the number of pages for this clustered index. Okay. So let me just fire this query. Now at this moment the data type is int, and I have fired this query, and you can see that my index is pk underscore customers. That's my index name. So the pk underscore customers is currently using 16 pages to store its data. Okay. Now let me go and change this int to probably a numeric, and let me save this data structure. And now let me go again and fire this query, and let me see that what are the number of pages. So you can see that the number of pages have now become 18. So that means my pages have increased. Why? Because the data type or the data size has increased. So which means that any queries which will be using this index will now perform, the performance will be a bit less as compared to using an int data type. So, again coming back to our statement, what we said, whenever you are given a choice to create an index between two data types, whichever data type is having less number of size, or which is having basically a less data type, should be chosen as a clustered index or a non-clustered index. So concluding what we demonstrated, we saw that when we created a index on an int data type as compared to decimals, we saw that the number of pages were increased. And because the number of pages are increased, SQL engine has to make an extra jump between pages to fetch data, and which means there will be a degradation in your SQL query performance. So concluding what we discussed, point number 4, keep index size as small as possible. I'll rather say, try to choose int as your index type, because I've seen that int is smaller as compared to a decimal or as compared to a double, and second, int is a numeric. Okay. So the smallest numeric data type what you have in SQL Server is int. So wherever possible, try to use int as your data type, because your number of pages will be reduced and the SQL engine doesn't have to make that extra jump between pages to fetch your SQL row or data row. I hope that this session was useful. In the coming up sessions, we'll try to see that, what are the best practices to choose indexes on data types. So in other words, is nchar or nvarchar a good data type as compared to int, or what are the other possibilities? And after that, what we'll do is that we'll also look into something called as indexed views, which actually increase your SQL query performance in a much better way. So keep tuned yourself in this whole video series, and I'm sure that the way you do your SQL performance tuning will change when you go through these videos.